Okay. System. You got an x minus here and a y minus x here, so it's kind of an antisymmetry. Maybe a symplectic thing or whatever. But, and we don't know what that means, but that's okay. Okay, so we got to transform x double prime. Well, that's just s squared L of x minus x prime of 0 minus s x of 0 plus Laplace transform of x plus Laplace transform of y. And see, there's a mistake I'm trying to make already, because that plus ought to be minus. Then we have, and that of course equals 0. And then we have, I'm going to do the minus L of x first, trying to keep the x's to the left of the y's. And then it's going to be plus s squared L of y minus y prime of 0 minus sy of 0 plus L of y equals 0. That's a little longer than before because you got all these second derivatives to do. Now we probably have, I'm not looking at the initial conditions yet, but probably some of these initial conditions, the x of 0, x prime of 0, the y of 0, the y prime of 0 are going to be 0 just to make this a little more accessible. Also because a lot of times when you're looking at a system you want to have good control over what initial conditions you look at. And often letting a lot of them equal 0 is going to be helpful. Okay, well we simplify, we just do algebra now. We're going to get s squared plus 1 times the Laplace transform of x, which is ordinarily going to give you like an s squared plus 1 in the denominator, and you're going to have a sine or cosine of t. But that's just kind of anticipating. And then we're going to have minus L of y. And then we just have numbers and s's, symbols, over on the right-hand side. That's going to be x prime of 0 plus s x of 0. And just giving us a good look at what we've got. Now, down here, we're going to have a negative L of x plus s squared plus 1 L of y, and that's going to equal negative y prime of 0, no, it's going to equal y prime of 0, because those are both positive, plus s y of 0. Now one thing, you don't want to try to solve these by elimination, although you could, but the elimination would involve expressions in s and would be harder than just, solve for L of y or L of x and then plug into the other. Okay? Well, the second equation is easy to solve for L of x. So that's what I'm going to do, and then when I substitute back here, the first equation will be an equation in terms of L of y. So we get this, we just write it down and get the negative of this thing over on this side and everything else repeats. So now what do we have? The first equation gives us s squared plus 1 L of x, But now that's s squared plus 1 times y prime of 0 plus sy of 0. And we want to keep our eye on the s's because that's really what's going to dictate pretty much everything. So this is what we get out of our s squared plus 1 L of x when we substitute this expression for L of x. Now if you see me do something wrong, holler, but it's inevitable that I will apparently. But okay, well then this is minus L of y, and that's going to be x prime of 0 plus s x of 0. Now again, we know that these x prime of zeros and x of zeros and y prime of zeros and y of zeros, it's just going to be numbers. Those are going to be our initial conditions. So those are just going to be straightforward. Now what do we have? Well, we want to isolate L of y over here. So what do we have on L of y? We've got s squared plus 1 times negative s squared plus 1 on L of y. So that's negative quantity s squared plus 1 squared minus 1 times L of y equals I'm going to go ahead and write it this way, and that should be a minus there. Okay, now all this is just numbers and an s. Okay, s squared plus 1 quantity squared is s to the 4th plus 2s squared plus 1. This is just going to give us s to the 4th plus 2s squared. No, wait, well, no, it's minus. That's going to give me a minus 2. And I'm not sure I welcome that because that's going to involve, well, it might. Okay, doing the arithmetic on this, now the reason I group these two and these two is because you're going to have two different types of functions of s. So you'll see. Okay, so you got x prime of 0 minus y prime of 0. Again, expanding this gives you a negative s to the 4th and a negative 2s, negative s squared, negative 2s squared. So you got an s to the negative s to the 4th and a negative 2s squared. And then you got a negative 1 and a negative 1, which gives you a negative 2. Again, which makes me think I've got a mistake there. And then I'm going to write this a little differently. I'm going to write this as quantity x of 0 minus y of 0, which is just going to be a number. And that's multiplied by then s over this denominator. Okay, so we just have a number over this and a number over this. Now this again, would require that we complete the square on this. For the moment, let u equal s squared and complete the square, and then go back to the s to the fourth and see what we have, and do the inverse transform. Once more, you get fractions in this thing that I don't think should be there. Yeah, you're not going to get the form of the solution. I mean, you somehow these ones probably should cancel each other. Because, well, just the form of the solution. So again, I have something kind of mysterious here. This denominator doesn't do what I want it to do. But I'm not going to pursue it. You just have a number over this, and a number times this over this, and you apply the initial conditions. The initial conditions, let's see, x prime is -2 and y prime is 1. So that's going to be a -3 there. And over here, x is 0 and y is 0 are both 0, so you're not going to have to worry about this one. Now you don't have that problem, but the way the text is set it up, x is 0 and y is 0 are both 0. So you have both systems, in a sense, stationary at the initial instant. But both systems in motion at the initial instant. When I say they're stationary, I'm sorry, they're like at equilibrium at the initial instant and in motion at the initial instant at different velocities. Okay, x prime 0 is -2, so x is moving in the negative direction, y is moving in the positive direction, whatever's moving or whatever's flowing in a circuit or whatever's going on to give you this equation. Okay. So again, you see how this evolves, and you see that other than the algebra, there's nothing unusual or intimidating about this. There's no new algebra. You just got to do the algebra of the system of equations carefully, and then you got to do your inverse transforms carefully.